So in this question we're looking at cosine of theta on 2 is equal to 1. So again, just treat theta on 2 as an angle and take the inverse of the angle again. So inverse cos of 1 will always be equal to 0. It's always going to be on, the related angle is going to be that x-axis. So it doesn't move from the x-axis. Any cos of anything on the x-axis is going to be equal to 1. So when we look at this, theta on 2 would be equal to 2n times pi plus or minus 0, so we're really just getting rid of that. It's equal to 2n times pi because it's going to put us on that axis. Theta on 2 is equal to that, so we've got to multiply it by 2 because theta's got to be equal to 4 pi n then, solving it like we did before. So in question 6, again we're just solving different types of equations. So 2 sine squared x is equal to 1, so equal to a half. Take the square root of both sides, and remember we're going to get that positive and negative. So you're solving the positive. So really we're looking at all 4 quadrants in this case. It's going to be going off in all 4 quadrants there. Inverse sine, the related angle gives us pi on 4. So when it's in the first and second quadrant, it's going to be the n times pi, and it's going to be adding minus 1 to the power of n. So that's going to give us a positive. So n times pi is going to give us the first quadrant, and adding pi on 4, and then when you're going n times pi, we're going to subtract negative 1 to the power of n, pi on 4. So this one's going to give us the ones in the first and second, this one will give us the one in the third and the fourth. And notice all it is just a change in the sign, because n times pi is going to put us on the different axes, and then we're adding or subtracting the number there, and adding or subtracting the number there. Going back to our trig rules from our 3-unit course here. So cos of 2 theta equal to sine theta. We want to, seeing that sine theta, 2 theta can be converted down to something in terms of sine theta, and we're solving this quadratic. Going through 2 sine theta minus 1 comes down to sine theta is equal to a half, and again sine theta is a half. We're looking for that related angle of pi on 6. The theta is going to a related angle of pi on 6, and we're applying our formula where we're in on both axes, and then going pi on 6 in either direction there. So as well, we've got alternate our axes, but alternate adding and subtracting at the same time. Sine of theta is equal to would be equal to minus 1. Again, in this situation, we can look at the case where we're going to be being on the negative y-axis. So this is one of the formulas. There's probably there's other formulas you could use. Again, you could look at the idea that you're going to go to 2 pi times n each time, and then subtract pi on 2, because that will always get you back to this axis, and then going back to pi on 2 to get you back on the negative y-axis. Sine squared x is equal to sine of x. Remember, never cancel these ones. Take it across, factorize. Sine of x is equal to 0. Sine of x is equal to 0 on both the positive and negative axis. So it's just, the pattern would be just n times pi. Get down to the positive, get it on the pi on the axis, and it's going to be equal to 0 each time. Sine of x is equal to 1. So again, we've done that one before. We were looking, that's at pi on 2 there. So we can use that rule, or we could have x being equal to 2n times pi plus pi on 2. Quite happy to have that as well. Question 9. Again, we've done these ones before, so it's just a case of using the idea with a general formula. So again, take your inverse of root 3 would give you pi on 3 as your related angle. So tan's negative in the second and fourth quadrant. So that's why we get the idea of getting onto the axis, x-axis, by n times pi, and then subtracting pi on 3 each time. So theta minus pi on 3 is equal to that expression. Add pi on 3, and they will cancel, and just leaves you with theta times is equal to n pi. Sine of x is equal to cos of x. Well, we know that would give us a situation where those two are equal when tan of x is equal to 1. Again, we're in the first and the fourth quadrant, so we're going to have n times pi, because it's going to put us on an axis, and we're going to add the related angle, which is pi on 4 each time. Again, tan of x is equal to sine of x. change tan of x to sine of x on cos of x, and then multiply through, collect our terms on the same on one side, set it equal to 0 then, and then solve each both equal to 0. Sine of x is equal to 0 gives us n times pi, and cos of x equal to 1 would be on the just on the positive x-axis, so 2 times pi times n would be our solutions to those equations.